Hello everyone, this is an introduction to graphing calculators, specifically the TI-83 and TI-84. There are some subtle differences between the two, but for the most part, they're laid out the same and have the same functionality. So I'm going to be using a TI-83 I have. I've lost my TI-84, but everything I go over should be applicable. This is made rather hastily, so I apologize for video quality and audio quality and everything else, but hopefully it'll be good enough to get you guys started. All right, so we have our calculator right here, and to get started with, sorry for the sound of my dogs in the background. Get started with, let's just get familiar with it. So we have a regular number pad down here, the mathematical operators you'll use most often there. We've got some trig right here, some other special functions over here, and then the second and alpha buttons, and then some setting buttons up here, and then cursor keys. The power button is down here, so we'll go ahead and turn that on. And I'm sure you've probably figured it out at this point. You can just type in things. You type in whatever your number in your operator. You can put in multiple steps in one and press enter, and it will solve it for you. Some more advanced steps you can take is that you can use variables in there. So say we have some function that we want to put in there, like 15x plus 3. You can do the math based on whatever value you have for x, and you can change that. So you can say, I want to put 3 in x. So you do whatever your number is, this store button, and then whatever variable you want, and then you can do second entry to bring up previous things you've entered. So I did second entry twice to bring me back up to 15x plus 3, and now you see I get a, oh, I forgot to store. So 3 store x. Now I get that value. And you're not limited to x. If you use the alpha key, you can use any letter in the alphabet. So I can do, ax squared plus bx plus c, and it will go and put whatever values you have in there. Now, right now, a, b, and c don't have any values, but if I do store A, store B, store C, get back here, I can do that. And then you can iterate through things as you wish. And then of course you can, do A times B divided by C or something like that. Quick thing to note is that, it'll automatically multiply like that. There isn't a distinction between, ABC versus AB versus A versus B versus C. That this is each individual letter. On more advanced calculators, this would actually be its own unique variable, but the TI-83 and 84 don't have that functionality. Okay, so that's some basic stuff. Kind of already did this, but if you need to access some other functions, you can look above the keys and you press the corresponding color to get that ability. So to get all of those different letters, I hit alpha first and then A, B, C, or anything down here, theta down here. Quotes, if you use some stuff, there's a space, question mark. And then second for some of the other things, like if you need to do a square root. So those are fairly straightforward things you can do. Let's get into some more advanced steps. So this is a graphing calculator, and so the way you can input graphs is by putting them in here under the y equals button. So if we press the y equals button, we bring this up. And we have a list of functions here, all y equals to. And let's do something like 1 over x plus the square root of x. Put the parentheses in there to close it off. You do have to use x in this. It assumes that x is what you're putting in there. If I put a in here, they would just be treated as a constant. Oops. So I have already set this up to a different window to look like this, but normally what's going to happen is it's going to start out here. I did zoom, standard, and this is what it'll start off at. And you see it'll go and crunch through it and draw the graph in there. And from that you can get some information about it and make some conclusions depending on what problem you're working on. But say you're looking for a particular area of it or of interest, you can do zoom. You can do zoom in, zoom out. I like to use zoom box. And then what you do is you set the cursor at the corner of a window, press enter, move using the arrow keys, highlight a box, and then it will zoom in on that box. So there we go. We've got a little bit better view of it. And right now it's set to trace along the function. So I can go left and right and it'll tell me. So at 1.215 blah, blah, blah equals 1.93. And so if you're looking for a particular value, you can go back and forth and see where it goes one or the other. Oh, no, it's not on trace. It is actually just going through space. So you can try to get the cursor on a particular spot and estimate it that way, but that's not very accurate. Instead, what you want to do is trace. So if you hit trace, it'll automatically jump to the nearest function. You can press up or down if you have multiple functions to jump between them. I only have one function, so it's only doing that. But then you go back and forth and you can find the values there. So it's not super precise. If I'm trying to find a value of y equals 2, I can tell it's between 2.573 and 2.63. But that's not super accurate. It's just kind of an approximation. To get a more accurate value, what we can do is we can find an intersection. So we want to find when y equals 2. So one thing we can do is put in the function y equals 2. I accidentally deleted this. Go and re-enter it. So y equals 2. If we graph it again, draws one graph and draws the other graph, we can actually see it looks like it intersects in two places because it goes down below it and comes back of it. Let's zoom in a little bit more. This will be really exaggerated. You have to be careful when you're doing the zoom because it will distort it, whatever you tell it to do. So this is going to be very stretched out in the y direction, but it'll make it more clear when we're doing other stuff. So there we go. We can see there's two clear points where y1 and y2 cross each other, or where they're equal. So again, if you hit trace, you can go back and forth between them. You can move over next to it, but again, you're not going to get exactly a right value. You can get arbitrarily close by just zooming in over and over, but that's not a good way to do it. A much better way to do it is if you do second calc. If you can see there's a calc right above trace, second calc. You have options there for value, 0, minimum, maximum, and intersect. And then there's some other stuff that we do with calculus. We'll get to that later. Value is nice if you want to just type in a bunch of numbers. So you can do x equals 1 and it'll jump right there. You can do 1.5 and it'll jump right there. 1.75. You can just type them in and you'll get the values right off the bat. And again, up and down to jump between different functions. You can also find something like where the functions intersect. So you see, you go second calc, intersect, and it's asking you first curve. So press up and down to whichever curve you want to use. It'll tell you the second curve, up and down, and then guess. So I'm just going to move this just arbitrarily close. It doesn't have to be right on the money. And then we find it, 2.618, blah, blah, blah. Y is equal to 2 is where those two cross. And the neat thing is, since you've solved it in here, if you use x, that value will have been stored in the actual x variable. And you can also access the y function. If you do variables, tab over to y variables function, you have access to the y1, and it works just like a function. So you can do y1 of x, and boom, there you go. So if you need to test a bunch of y values, you can put them in this way. If you have a whole bunch of them that you need to do, it might be more efficient to use a table. So I'm going to jump to this over here first. It says table set, so second table set. Table start is where it will start counting from. Delta table is what step it'll take. So right now it's set to 0.1. And then you can set whether the independent or dependent variables are automatically entered, or you can ask for them. I have my independent variable set to ask because I usually have specific points I'm looking for, but the dependent variable will be automatically calculated. So then what we do is do second table. And all of these values are already in here. I should have cleared this out ahead of time. But you'll start off with something like this where it's blank. So you can type in a value. And you see here, our y1, we got an error. Because if you remember, it's 1 over x. So 1 divided by 0 is undefined. We got an error there. But y2 works. So we get -2. If we do -1, same thing, error 2. We can do 1, we can do 2. We can put x in there, and you see, hey, look, it works. So if you have a bunch of different values that you have to test, this can be a quick way to put a bunch. And then once you get to the bottom, they start overwriting each other, but that's not a big deal. So go back, second quit to go back to the main screen. Sorry if I didn't mention that already. What else? Let's go back to the graph. If you need to find the minimum point, under second calc, there's another. You can see minimum or maximum. So let's find the minimum here. Left bound, and you don't have to use the arrow key all this way. You can actually just press a number in, and it'll go there. And there you see, it popped it up there. Now the right boundary, the other boundary we're going to try to find, let's do 2. And then a guess, just move it in the direction somewhere. It doesn't have to be too close. And there we found the minimum, x equals and y equals. So, our x is this, and our y value is that. Another way you can do it is, say you wanted to solve this function equals 2. Instead of finding the intersect, you can solve it so that y is equal to 0. So you do, y equals 2 and y equals 1 over x plus the square root of x. So you move the 2 over and it becomes -2. I'm going to have to zoom standard. And you saw there, I went and pressed the number that was next to it, 6, to go straight there. Now we see our graph actually crosses the x-axis. So let's go and zoom in on that. And now we can find the 0. Functionally, it's the exact same process as when you're doing the intersect. It's just assuming that y equals 0 is one of your lines. So there you go. X equals 1, y equals 0. The thing to remember, though, is that we're looking for y equals 2. So you have to be careful to remember, okay, I'm actually looking for this first part of the function equals 2. And so the value there isn't just y of x, it's or y1 of x is a slightly different function. So you had to keep track of that. What else can we do? If you go under math, we have things like convert to fraction or convert to decimal, cube and q root. This is the xth root. And then we have f-min and f-max. So with these, you don't have to actually go and do the graph of it. You can do it by just putting the function in. So the format for this is the function, then the variable that function is, the left bound, and then the right bound. So my function is 1 over x plus square root of x, comma, the variable I'm finding the minimum of is x. My right bound, I'm just going to say 1. Left bound is 2, close parentheses. And there it finds it. And you don't have to put your whole function in there. If you're going to be using it a lot or doing other stuff with it, you can put y1 in there. So in this case, I'm going to do second insert f-min, put that in there, x, 1, 2, and it does the same thing. Let's see, what else? Mode has a lot of settings, so whatever format you want your numbers to be in, how many decimal places to keep it, radians and degrees, this is the most important one. If you're doing any trig functions, you'll want to make sure that you're doing it in either radians or degrees, whatever you're dealing with. If you're doing polar or parametric equations or sequences, you can switch between them. We're not going to be dealing with those, but this is where you go and switch it. If you have a function in the form of a polar plot, you'd go and switch it over there. This is how you graph. This is the format for complex numbers. And in this case, it's just saying only do the real values, but you can find the a plus b complex number, or you can do the re to the theta I, basically the polar form of complex numbers. And then there's a couple others that I'm not going to go over. I'll skip that. Let's see, what else is in math? Absolute value, rounding, the imaginary part. Sorry about my cat if it's showing up. Find the integer of, min, max. These are mostly useful if you're doing any sort of programming. You can write programs if you're doing some sort of process pretty frequently. I used it to good effect in high school and college. That's a little bit more advanced. Conjugate real, a bunch of other stuff. Probability. What else? Did tables already. If you know of a particular operation you want to do, but you can't remember where it is, there are a lot of menus and submenus and stuff, you can do second catalog and jump right there, and it'll have an alphabetical list of every single function that you can do, and then you just press the button that corresponds to the letter what you want. So if we want to do as like f-min, but I can't remember where f-min is, if I go and press F, it'll go straight to F. Hi Gus. And there it is. You just go down to f-min and find it that way. What else? I did tables, I did graphs. Did all of the min, max, zero, the value, derivative and integral once we get to that. If your calculator is all messed up and doing weird things and you can't figure out how to do it, you can do second format. Oh, excuse me. This is the format for the graphing. So sorry. Coordinates on or off, grids on and off, axes on and off, labels on and off, and then the expression on and off. So if your graph is cluttered, you can change it that way. Let's see. There's some cool stuff you can do with statistics, but I'm not going to go over those. There's some really powerful things you can do with lists and solving systems of equations, but that's a bit involved. I'm not going to go over that, but if you have questions about that, ask me, and I'll be happy to go over that, how you can use lists. Let's see, apps. Yeah, there's some useful tools in there. And then if you need to do degrees, minutes, degrees, minutes, seconds, convert, blah, blah, blah. All right, I think that's most of it. Oh, and if you need to change the contrast, you see there's this little contrast button in yellow, so you can hold second, and then you can actually, let's see, second alpha lock. If you're going to be pressing a lot of letters, you can do alpha lock. Why is this not working the way I think? I guess you just have to alternate pressing them, but that's, if you need to change your contrast, like you're having a hard time seeing it, you can make it darker or lighter. That way. Matrix operations, there's some really, really useful things you can do with that. Oh, and the second answer can be handy to use if you need to do an expression. Usually I just do store to x and then do everything in terms of x because it's faster to just type x than second answer, but you can still use second answer. So 1 over answer plus the square root of answer if you're doing something like that. And then, you can do second entry to bring it back up. Yeah, memory is where if you need to reset your calculator because it's doing weird stuff, that's where you'd go. Then memory management, if you have a whole bunch of variables or something you want to delete, you can do that. You can also do it in here. Where is it? Anyway, hopefully that was helpful. Let me know if you have any questions. Yeah, see, here it has Y1 here. I can go and delete it from within there, or you just go in here and hit clear. Let me know if this was helpful or they have any questions, and I'll be happy to let you know. Oh, one other thing that can be helpful is this second test. These have all of the operator tests as well as logical operators, and it will tell you if your response is true or not. So 5 is greater than or equal to 3. You give a 1 for true. If I do that, I get a 0 for false. So this is more useful if you're doing programming, but if you have two functions, say, y1 greater than y2, whoops. The important thing, though, is that it's got to be y at a particular value. It won't be able to test if it's it's invalid because I don't have functions in there. But it won't be able to test whether it's true over the whole function. You need more advanced calculators to be able to do that. Anyway, hopefully that was useful. Let me know if you have any questions, and see you in class.